welcome yet again to another math lesson for the upper basic level. And this would be like our lesson 5, which is a continuation of lesson 4. Because if you remember on lesson 4, we were dealing with inverse operations and solving one-step equations. Now, just to take you back a bit before we move on the inverse operations, we have learned which operations undo each other. Like, we now know to undo an addition, you subtract. And likewise, to undo a multiplication, you divide. So a subtraction will undo an addition, and an addition also will undo a subtraction. Likewise, a multiplication will undo a division, and a division will also undo a multiplication. Now, in our previous lesson, we looked at one-step equation, like if you have x minus 1 equals to 7. We know to solve this, we are only required to have one step. Only one step will lead you to answer. And by the way, we also know to solve, you are simply being asked to do one thing. You are simply being asked to isolate the variable on one side of the equation. That is all you are doing. Now, once the variable is all alone on one side of the equation, then you have solved. Now, so if I want to solve this, look at where the variable is, and together with the variable, you can see that there's a -1, which we need to undo, and we know to undo a negative, you add. So to undo a -1, you just say +1. But remember, we said whatever you do to one side of an equation, you must do the same thing to the other side. So if you add 1 to the left-hand side, then you must also add 1 to the right-hand side. And that will give you the -1 plus 1 will cancel each other out. Then you're left with x is equal to 7 plus 1 will give you 8. And if you look at here, already, x is alone on one side of the equation, and that is all we were trying to achieve. Now, once the variable is on one side of the equation, that is your work done. Now, our today's lesson is going to be on 2 steps now. This was only taking us 1 step to get to the answer. Now, let's see what happens here. Sometimes it takes more than 1 step to solve an equation. Remember that to solve an equation, or to solve equations, you must walk backwards through the order of operations to find the value of the variable. Now, we all know the order of operations, what we call both mass. That is the order in which we generally use to evaluate an expression. But then, when solving an equation, you walk backwards through this order, which means you start from subtraction, addition, going right down to the brackets. So we don't divide before subtracting. Instead, we subtract before dividing. So we are going backwards through the order of operations. This means that you undo the opposite order. First, addition and subtraction, which are normally the last 2, but here they become the first 2. Second, multiplication and division. Third, the exponents, if there are. And then fourth, grouping the symbols. So that is the order in which we use when we are solving equations. So this should be a quick reminder for you. Subtraction, addition, division, multiplication, exponents, and then grouping the symbols. That is the order in which you follow, reversing the both mass. Now we say one way to remember the reverse operations would be Sad Meg. Let's assume that Meg is the name of a person. When he or she is sad, we call sad Meg. That would be an easy way to remember this, that we are working through this. Subtraction, addition, division, multiplication, exponents, and grouping. So we are flipping the both mass here. Now here's an example. If we are given 4x plus 2 equals 10. Now to solve that equation will require more than one step. But look at where the variable is. We have 4x plus 2. And remember, we are simply trying to isolate the variable. So we have 4x plus 2 on this side. We want our variable to be alone. But if you were to break this down, you end up having 4 times x plus 2 is equals to 10. Now that is the extended part of this. So 4x plus 2 actually reads as 4 times x plus 2. Now in that case, where the variable is, we actually have two operations. We have a multiplication and then we have an addition. But because we are going backwards through the order of operations, we must undo the addition before the multiplication. That is why you can see first you have positive 2, and to undo a positive 2, you have to subtract 2. So if I subtract 2 on this side, because I know that whatever I do to one side, I must do to the other side. If I subtract 2 on this side, I must also subtract 2 on this other side. So subtract 2 on the left-hand side and subtract 2 from the right-hand side. That means you are undoing the addition first. And of course, that will eliminate the 2's. But the 4x is still there. So it comes down. And then the 10 minus 2 will give you 8. So in the end, you'll be left with 4x equals to 8. Again, we know 4x is 4 times x. So the operation there is multiplication. And to undo a multiplication, you divide. So therefore, we divide by 4, we divide by 4. Notice that we are dividing both sides by 4. And that will undo this 4 from here. Your x is now alone. And of course, 8 divided by 4 will give you 2. So that is our problem solved, because our variable is all alone on one side of the equal sign. So the solution here is x equals to 2. Always remember, whatever you do to one side of an equation, you must do to the other side. That's very important to remember all the time. Now here's a similar example. You have negative 2y minus 9 equals negative 13. Now on the side where the variable is, you have negative 2y minus 9. Now since we are going backwards through the order of operations, it means we need to undo the subtraction first. And to undo a subtraction is addition. So to undo a negative 9, you have to add 9 to that side. But of course, if I add 9 to the left-hand side, I must add 9 to the right-hand side. That way, the 9's will cancel each other out, because negative 9 plus 9 will amount to 0. But the negative 2y is still there, so you bring it down. You bring down the negative 2y. And then, negative 13 plus 9, if you apply your integers knowledge, that should lead you to negative 4. Then now you are left with negative 2y is equal to negative 4. Still, between negative 2 and y, we know that there's a multiplication there. And to undo a multiplication, you divide. So therefore, we divide here by the negative 2, so that negative 2 will cancel negative 2 out, and then the y will be alone. But whatever we do to one side, we must do to the other side. So therefore, we also divide the right-hand side by negative 2. That way, the negatives will cancel out. So there will be no negative in the answer. And then, 2 can go into 4 2 times. So therefore, your answer to that question becomes 2. Y is equals to 2 is the solution. Let's try to go through this together. We have about 3 questions here. Let's see if we can solve each one of them. The first one is 5b plus 3 is equal to 18. Now remember, all we are still trying to do is to isolate the variable on one side of the equation. Now look at the side where the variable is. We have 5b plus 3. 5b is 5 times b. That's a multiplication. And then you have addition. Now which one do we undo first? Remember we said we go backwards through the order of operations. So therefore, we need to undo the addition before the multiplication. And what we have there is positive 3. And to undo an addition, you subtract. So subtract 3 on this side, on the left-hand side. But again, whatever I do to one side, I must do to the other side. So if I subtract 3 from the left-hand side, I must also subtract 3 from the right-hand side. And then what's going to happen? The 3 will cancel out the 3, because again, 3 minus 3 would be 0. So they just cancel out. But still, the 5b is there. So you bring down the 5b. Equals 18 minus 3 would be 15. We are trying to isolate our variable b on one side. But right now, the b is still having a partner there. There's a coefficient there. So that 5 needs to go away from there. But of course, we know 5b is 5 times b. That's a multiplication there. And to undo a multiplication, you divide. So I will divide here by 5. Whatever I do to one side, I must do to the other side. So therefore, I must also divide this right-hand side by the same 5. The 5s will cancel out, and you are left with b being equal to 5 into 15 would be 3 times. So your solution is b equals to 3. Now we could apply the same steps to the second question, where we have w over 2 plus 6 is equal to 10. Still, we are trying to isolate our variable on one side. Look at the side where the variable is. We have w over 2. We know w over 2 is the same as w divided by 2 plus 6. So you have a division and then an addition. But since we are going backwards through the order of operations, we need to undo the addition before the division. So we need to undo the plus 6. And to undo an addition, you subtract. So I will subtract 6 from the left-hand side, which means I must also subtract 6 from the right-hand side. Because whatever I do to one side, I must repeat the same to the other side. Then what happens is, the 6's will cancel out, because again, 6 minus 6 would be 0, so they are gone. And on this side, you are now left with w over 2 will now be equals to 10 minus 6 should give us 4. Still, our question is not solved, because our variable is still not all on its own on one side. There is still a 2 there. But again, we said W over 2 is W divided by 2. So there's a division there, which we need to undo. And the inverse to a division is multiplication. So to undo this 2, we need to multiply this left-hand side by 2. Whatever I do to one side, I must do to the other side. So therefore, I must also multiply the right-hand side by the same 2. That way, the 2 cancels out the 2. I'm left with W on this left-hand side now being equal to 4 times 2 would be 8. Now, is our variable alone on one side? Yes. So therefore, we have answered the question. That is all we have been trying to do. And so by now, most of you have already worked out the third one. Now, let's go through it and see if our answers will be the same. 3j minus 4 equals 14. Again, on the side where the variable is, that is where our interest is, because we want to isolate the variable. We have 3j, which is 3 times j, that's a multiplication, minus 4, and that is a subtraction. Again, normally, we would have said multiply before subtract, but remember, we are going backwards through the order of operations, so therefore, we deal with the subtraction before the multiplication. So we need to undo the subtraction. We need to undo the minus 4 there. And to undo minus 4 is plus 4. I have added 4 to the left-hand side. I must add the same 4 to the right-hand side. And that will now give this first day cancel out because negative 4 plus 4 will amount to 0, so they are out. On this side, you are now left with 3j. Then you have 14 plus 4 would give you 18. Is our variable alone now? No. There's still a number there. We still have 3 there. And that is 3 times j. It's a multiplication. So we need to undo that. And to undo a multiplication, we divide. So, over 3 over 3, both sides. The 3's will cancel out, and your j is all alone now, equal to 3 into itself would be once, and 3 can go into 18 6 times. So the correct answer there would be j equals to 6. If you got that as your solution, well done. We still have 3 more questions to go through. And again, as usual, I'm sure some of you are writing and solving. And then you compare your answers to mine and see if you are doing the right thing. We have negative 2x plus 3 equals negative 1. I hope you write that. Then next we will look at negative 2m minus 4 equals 22. And then we will look at 1 over 3t minus 5 equals 0. Now, let's start with the first one. Negative 2x plus 3 equals negative 1. Again, we are trying to isolate the variable. We are trying to make sure the variable is all alone on one side of the equation. That's all we are trying to do. Now, where the variable is, we have negative 2x, which is negative 2 times x. That's a multiplication. And we have plus 3, and that is an addition. Which means we need to undo the addition before the multiplication, because again, we are still going backwards through the order of operations. And if I want to undo a plus 3, I simply subtract 3. But if I subtract 3 from the left-hand side, I must also subtract 3 from the right-hand side. that undoes the 3 from this side. There's no more 3 here, because 3 minus 3 would be 0. So they are gone. But still, the negative 2x is still there. So you bring it down. Equals. Now, minus 1 minus 3, if you apply your integers, should lead you to negative 4, minus 4. But is our variable alone now? No, there's still a number there. That needs to be undone from there. And negative 2x is negative 2 times x. That is a multiplication. So we need to undo that multiplication by dividing. Divide by negative 2 on the side, on the left-hand side. Then also divide by negative 2 on the right-hand side. The negative 2's on this left-hand side will cancel each other out. And of course, the x is now alone there, equals to, here we have negative 4 over negative 2. The negatives will cancel each other out, because when you divide a negative by a negative, it gives you positive. So they're out. And then 2 into 2, once into 4 will be 2 times. So the solution to that question should be x is equal to 2. Then let's move along to the next one. Negative 2m minus 4 is 22. Always focus on where the variable is, on the side that you have the variable. Negative 2m is negative 2 times m, multiplication. And then minus 4, subtraction. Which means we're going to undo the subtraction first. And if I want to undo negative 4, I'll have to add 4. Because I know the inverse for subtraction is addition, so I need to add 4. But I know also that if I add 4 to the left-hand side, I must also add 4 to the right-hand side. And that, the negative 4 plus 4 would cancel out. They come to 0. Still, you have negative 2m on that side, so you bring it down. And 22 plus 4 should give you 26. Now you have negative 2m, which is negative 2 times m, a multiplication. So we need to undo that multiplication by dividing. So I will divide the left-hand side by the negative 2. I will also divide the right-hand side by the same negative 2. So the negative 2 will cancel out negative 2 on the left-hand side, and you're left with m on that side. Now, at the right-hand side, we have 26 divided by negative 2. The 26 is positive, and the 2 is negative. And when you divide a positive by a negative, your answer would be negative. And then 2 into itself once, 2 goes into 2 will be once as well, and then 2 goes into 6 is 3. So in the end, your solution to that question should have been m equals to negative 13. Now, moving on to our third question, where we have 1 over 3t minus 5 equals to 0. Again, our focus is always on the side where we have the variable, because we want to isolate the variable. And on that side, we have 1 over 3t. 1 over 3 we know is 1 divided by 3. Minus 5. So we have a division there and a subtraction. And by now we know that when solving equations, you undo a subtraction before a division. So therefore, we need to undo the 5 there. 5 is negative 5. And to undo a subtraction, you add. So I will need to add 5 on this left-hand side and add the same 5 to the left-hand side, to the right-hand side, rather. And having done that, the 5's will cancel each other out because negative 5 plus 5 would amount to 0. So they are gone. But still, we are left with 1 over 3t on that left-hand side equals 0 plus 5 will give us 5. Remember, we are trying to isolate our variable. We need our variable to be all alone on one side. And since 1 over 3 is the same as 1 divided by 3, it's a division there. So to undo a division, we multiply. So you're multiplying the left-hand side by 3. But of course, whatever you do to one side, you must do to the other side. So if I multiply the left-hand side by 3, I must also multiply the right-hand side by the same 3. That way, 3 will cancel out 3. And we seem to be having 1t equals to 5 times 3 is 15. But of course, we do know that 1t is just t. So we can write that as t equals to 15. So in the end, our solution should be t is equal to 15. And I'm sure that is what you have arrived at as well. That's another question for us to try together. But again, I expect you to work ahead of me, so that when I get to the solution, you can now compare my solution to your solution and see if you got the same thing. 5x minus 6 is equal to negative 56. Now again, focus on the side where the variable is, because we have 5x minus 6 equals negative 56. That is our question. Now where we have the variable, 5x is 5 times x, that's multiplication, minus 6, that is subtraction. And we know by now you undo a subtraction before a multiplication. So we need to undo this minus 6. And to undo a subtraction, you add. You add 6 to the left-hand side, but also add 6 to the right-hand side, because whatever you do to one side, you must do to the other side. And this will give us minus 6 plus 6, we know is going to give us 0. Still, the 5x is there, so you bring it down. 5x is equal negative 56 plus 6. Refer back to your integers, and that should give you negative 50. But still, our variable is not alone on one side. There are still a 5 there. We have 5x on that side. 5x is 5 times x. It's a multiplication, which you have to undo. To undo a multiplication, you divide. So divide the left-hand side by 5. Also divide the right-hand side by the same 5. That way, the 5 will cancel out, and you are left with x now being equal to, the 50 is negative, the 5 is positive. We know if you divide a negative by a positive, you end up having a negative answer. So we know our answer is going to be negative. And of course, 5 can go into itself once, and 5 into 50 would be 10 times. So in the end, the answer to this question should be x is equal to negative 10. I hope that was your answer as well. Then we have another problem here. We have 14 is equal to 3c plus 2. We want to solve this. Remember, I said our focus should always be on the side where the variable is, because we are simply trying to isolate that variable. So we have 14 is equals to 3c plus 2. Now, where the variable is, we have 3c, that is 3 times c, multiplication, plus 2, addition. And by now, we know you must undo an addition before a multiplication. So we need to undo the plus 2. And the inverse to plus is subtraction. So we subtract 2 to the right-hand side. Also subtract 2 from the left-hand side. Because whatever you do to one side, you must do the same thing to the other side. And the 2's will cancel out because 2 minus 2 is 0. That's gone. And then the 3c is still there. So you get 3c comes down equals 14 minus 2 should give us 12. Right. Still, is our variable alone? No, it is not. You still have 3c there. 3c is 3 times c. That is a multiplication. So to undo that multiplication, we divide. So you divide the right-hand side by 3. Also divide the left-hand side by the same 3. Whatever you do to one side, you must do to the other side. This 3 will cancel out, and you have c there equals 4 into itself, 3 into itself rather, once. 3 goes into 12 would be 4 times. Is our variable alone on one side of the equation? Yes, it is. So therefore, that is our answer. Because it does not matter on which side the variable is. Whether it is on the left-hand side or on the right-hand side, that is not a big deal. That's not a problem. All we are trying to achieve is to make sure that your variable is alone on one side of the equal sign. And in this case, the c is definitely alone. So our solution is 4 equals to c, or if you want, that can be written as c is equals to 4. They mean the same thing. Right, now here's another challenge. X over 5 minus 4 equals 24. X over 5 minus 4 is equal to 24. Our focus is always on the side where the variable is, because we want to isolate it. That's our task here. And on that side, we have x over 5, which is x divided by 5, that's the division, minus 4, that's a subtraction. And by now we know you undo a subtraction before a division when you are solving equations. So we need to undo this minus 4. To undo minus 4, you add 4 to the left-hand side because the inverse to subtraction is addition. But of course, if I add 4 to the left-hand side, I must also add 4 to the right-hand side. That is something you can never forget, that whatever you do to one side, you must do the same thing to the other side. Then what happens then is the 4 will cancel out, because negative 4 plus 4 would be 0. So they cancel each other out. But still, you are left with the x over 5. So you bring it down. X over 5 equals, if you add 24 and 4, 24 plus 4 should give us 28. So now that gets us to x over 5 is equal to 28. Still, our question is not solved because our variable is not alone on one side. There's still a 5 there. But of course, it is x over 5, which is the same as x divided by 5, division. And to undo a division, you multiply. So therefore, I need to multiply this side by 5. Also multiply the other side by 5. So that this 5 will cancel out. And then you are left with x there now. If you multiply 28 by 5, you end up having we know 5 times 8 is 40. That will be 0, carry 4. And 5 times 2 is 10 plus the 4. That will give you 14. So therefore, our solution to this question would be x equals to 140. Now on to our next question. And that is 5r minus 2 is equal to negative 12. That is 5r minus 2 is equal to negative 12. Again, always focus on the variable side because you want to isolate it. 5r is 5 times r, multiplication. Minus 2 is a subtraction. And by now we know that you undo a subtraction before a multiplication when you are solving equations. So I need to undo this minus 2, so therefore I need to add 2. And if I add 2 to the left-hand side, I must also add 2 to the right-hand side, because whatever I do to one side, I must repeat the same thing to the other side. Then the 2's will cancel out, because minus 2 plus 2 is 0, so they are gone. But the 5r is still there, equals negative 12 plus 2. Again, you have to refer back to your integers, and that should give us negative 10. Still, our variable is not all alone. We have 5r. 5r is 5 times r, multiplication. So to undo that multiplication, you divide. So you divide the left-hand side by 5, divide the right-hand side also by the same 5. So that the 5's will cancel out. You get your r being equal to, the 10 here is negative, the 5 is positive. If you divide a negative by a positive, you get a negative answer. So the answer is going to be negative. Then now 5 into itself is once, 5 goes into 10 would be 2 times. So the solution to this question would be r is equal to negative 2. Now, let's get more problems. 14 equals to negative 2n minus 6. 14 is equals to negative 2n minus 6. That is our question. On the side where we have the variable, we have negative 2n there, 2 times n, multiplication, then minus 6, subtraction. As usual, we know we should undo a subtraction before a multiplication. So to undo the minus 6 is going to be, we are going to add plus 6 to that side, to the right-hand side. If I add 6 to the right-hand side, I must add the same 6 to the left-hand side. Then the 6 will cancel out because negative 6 plus 6 again is 0. But the negative 2n is still on that side. So we bring it down. Negative 2n equals 14 plus 6 will give us 20. Still, our variable is not all alone, because still we have negative 2n. Negative 2n is negative 2 times n. It's a multiplication which we need to undo. And to undo a multiplication, we divide. So over negative 2, divide here also by negative 2. The negative 2 will cancel out negative 2. So n is now all alone on the side. The 20 on this side is positive, the 2 is negative. You divide a positive by a negative, you have a negative as your answer. 2 into itself will be once, 2 into 20 will be 10 times. So in the end, your answer is negative 10 equals to n, or if you prefer to write it, you can say n is equals to negative 10. They are one and the same. Now, on to our next question, and that is x over 5 plus 7 is equal to 13. X over 5, that is x over 5 plus 7 is equal to 13. We're focusing on the side where the variable is, and there we have x over 5, that is x divided by 5, that's a division, plus 7, that's an addition. And by now we know you undo an addition before a division when you are solving equations. So therefore, I need to undo this plus 7. And the inverse for addition is subtraction. So therefore, I must subtract 7 from the left-hand side and also subtract 7 from the right-hand side. And that gives me the 7s will cancel out because 7 minus 7 is 0. But still, I'm left with x over 5 on this left-hand side. So I bring it down. X over 5 equals 13 minus 7 should give us 6. But still now, our variable is not alone because we still have x over 5 equals to 6. So the variable needs to be alone. X over 5 is x divided by 5. So we need to undo that division by multiplying. Multiply by 5 on the left-hand side, multiply by 5 on the right-hand side. Then the 5 will cancel out the 5. You have x. And then 6 times 5 should give us 30. So our solution to that question should be x is equal to 30. And we move along. Still, we have more questions to try together. Negative x over 3 plus 2 is equal to negative 10. Now, there is something we need to remember here. Where we have negative x over 3, we have gone through this before. That since there is only one negative there, it is either assigned to the variable x or assigned to the 3. But we said to avoid having a negative variable, it is advisable that we assign the negative here to the 3. That makes it easier to work with. So therefore, we can write this as x over negative 3 plus 2 is equal to negative 10. That makes life a lot easier. Now, x over negative 3 is x divided by negative 3. That's the division. Plus 2 is an addition. So therefore, we know we need to undo the addition before the division. Therefore, we must subtract 2 from the left-hand side, also subtract 2 from the right-hand side. Then that happens, the 2's will cancel out, but still on this left-hand side, we are left with x over negative 3. And that should be equal to negative 10 minus 2 should give us negative 12. But yet still, our variable is not alone, right? There is still a 3 there. So we need to undo that negative 3. But x over negative 3 is x divided by negative 3. That is a division, which we need to undo. And we know to undo a division, we multiply. So we multiply this side by the negative 3. You also multiply the right-hand side by the same negative 3. Then what happens is, your negative 3 here will cancel out this negative 3. And now your x is all alone. Now we have negative 12 times negative 3. Now when you multiply a negative by a negative, they turn to positive. And then 12 times 3 will give us 36. So the solution again to this question is x equals to 36. So by now, this has become really easy for you to work with. But again, walk ahead of me and then follow my steps and see if we arrive at the same answers. 2 over 5x minus 3 equals 9. Okay? 2 over 5x minus 3 is equal to 9. That is our question. 2 over 5 is 2 divided by 5. That's the division. Minus 3 is a subtraction. And by now we know you undo a subtraction before a division. So therefore we need to undo the minus 3. So we add 3 to the left-hand side. We also add 3 to the right-hand side. And what this gives us is that the 3's will cancel out because negative 3 plus 3 is 0. But still, we are left with 2 over 5x. So we bring it down. 2 over 5x equals 9 plus 3 should give us 12. That is where we are now. We have 2 over 5x equals to 12. But still, our variable is not alone. So we need to continue working. We have 2 over 5, that's 2 divided by 5, equals to 12. So next, we need to undo the division. And to undo a division, you multiply. You have multiplied the left-hand side by 5. You also multiply the right-hand side by 5. The 5 will cancel out the 5. Now we are left with 2x here on the left-hand side equals to 12 times 5 should give us 60. But still, is our variable now alone? No, it is not. So we have to continue. 2x is 2 times x, multiplication. So we need to undo that multiplication. And to undo a multiplication, you divide. So over 2, here also over 2. Then the 2 will cancel out. So you now have your x. 2 into itself once, 2 into 6 is 3 times, into 0 is 0. So, is our variable now alone? Yes, finally it is alone. So therefore that is our answer. So the solution to this question, again, would be x is equal to 30. That is our solution. Now this looks quite similar to the previous one. So therefore, solving it should not be a problem to you at all now. Again, let's see. Let's go through it. 2 over 3x plus 3 equals 4. 2 over 3x plus 3 equals 4. Again, on the side where you have our variable, that is where our focus is. We have 2 over 3 there, that's a division, plus 3, that's an addition. And we know you undo an addition before a division. So we need to undo that plus 3. The inverse to addition is subtraction. So therefore, I must subtract 3 from the left-hand side and also subtract 3 from the right-hand side. That way, the 3's will cancel out because 3 minus 3 is 0. And now I have still on this side, on the left-hand side, as 2 over 3x equals to 4 minus 3 would be 1. But still, our variable is not alone. 2 over 3 is 2 divided by 3. So we need to undo this division. And we multiply to undo it. So multiply this left-hand side by 3. Also multiply the right-hand side by the same 3. So that 3 will cancel out 3. But still you have 2x is equal to 1 times 3 would be 3. But our variable is still not alone. We have 2x still, and that is 2 times x. So we need to undo the multiplication by division. So I will divide by 2 and divide by 2. This is going to cancel out the 2's. And then now you have x as 3 over 2. Is our variable alone now? Yes, our variable is alone. So therefore, our solution to this question is x is equals to 3 over 2. Now here comes our next question. Negative 2.5x minus 4 is equal to 3.5. Okay? Negative 2.5x minus 4 is equal to 3.5. That is our question. Let's go through it. Negative 2.5x is negative 2.5 times x. That's a multiplication. And then you have minus 4 is subtraction. So we undo the subtraction before the multiplication. So we add 4 to both sides. Add 4 to the left-hand side. Also add 4 to the right-hand side. And this leads us to the 4's will cancel out because negative 4 plus 4 is 0. But still we have the negative 2.5x. So we bring it down. Negative 2.5x equals 3.5 plus 4, if you add that properly, should give us 7.5. Right. Still, the x or the variable is not alone. So therefore, we have to divide it by both sides by negative 2.5. So we divide the side by negative 2.5. You also divide the right-hand side by the same negative 2.5. The negative 2.5 will cancel out. So now x is all alone on this side. The 7.5 is positive and the 2.5 is negative. You divide a positive by a negative, you get a negative answer. And of course, 2.5 into 7.5, if you divide properly, should give you 3. So therefore, our answer to that particular question is x is equal to negative 3.